Let's look at using the law of cosines now. We're going to use these formulas, which are really actually all the same. The only difference is that you're using A or B or C, and depending upon which angle you use, you have A, B, C here, BC, AC, AB. So it's just a matter of what you have and what you want. Oh, and then BC, AC, and AB. Lots of places they go. Well, let's go ahead and actually just do one. So we're going to solve a triangle given two sides and the angle between. Right? So when I look at this, I see if that's A here, then this has to be angle A. And if this is B here, then this is angle B. And that means this has to be angle C in lowercase c. So solving the triangle means that we are going to find the three things we don't know. And those three things are the two angles and the side C. So we're going to find those three things. And I look at it, the information that's given, I have one angle, which is C, and the two sides on this, and that angle is between two sides. That means I can use one of these formulas. In this case, I'll use this one. And they're all the same. It's just a matter of which direction, which thing I use. So given this information that's in that triangle, the formula to use is, and I'll do this sort of as my number one step. Formula is C squared equals A squared plus B squared minus 2AB times the cosine of angle C. This one right here. And we can do that because we don't know what C is, but we know what A is and B is. We know A and B, and we know the angle C. So all we have to do is solve for this. So C squared is equal to 15 squared plus 28 squared minus 2 times 15 times 28 times the cosine of 82 degrees. So now it's a matter of calculating these things. 15 is 784, 28 squared. Oh, wait a minute, I got the numbers off. That's so I'm gonna put them in order here, this team, because 15 is 225 and 28 squared is 784. I'm going to multiply these other numbers together, 15 times 2 to 28, and that gives me 840. And then the cosine of 82 degrees. So to continue with this, C squared is 1009 minus 840, cosine 82. Now here is a place to watch out for where people sometimes make errors. This is what we have, and what some people will do is that they will accidentally look at this and they'll do that subtraction. A problem with that is the order of operations. The order of operations says that you have to do this first. You have to do the multiplication that's in here, that's implicit, understood between a number and something like cosine of 82. So we have to do that first. So if we do multiply that out, you get 1009 minus, and once you do that, it comes to approximately 116.91. You would actually want to do that on a calculator and leave it there so it would work it all out correctly. So C squared, and now actually have that approximately, because I just had to round something. Okay, and that comes to approximately 829.09. Now let's take the square root of both sides, and C is approximately 29.87. And if we do that, then that means it's really approximately, it's very close to 30 units. So that's our first thing. We now know 30 units. And I did that through using this formula. And I had these things I could fill in on it. I had A and B, and I knew the angle amount of C. And it gives me approximately 30 units there, all right? So I will put that as 30 units. That's one of my answers. And now we have to find angle. So actually, let's do this, part one here. The second thing we're going to do now is find one of the angles. And we can use the law of sines to do that. So I'm going to use that sine A. Oh, but I don't know what A is. But I do know the lowercase a. I know the amount of that. And I now know C. I know this and I know this to C. So I can do sine of C over C. And the way that will calculate out is now I don't know what sine of A is, but I do know that lowercase a for the length of the side is 15. And then I can say sine of 82 degrees. And I now know that the side amount for C is about 30. Okay. And so if I want to solve for sine of A, I'm going to multiply both sides by 15. So I'll have sine of 82 degrees divided by 30. Okay. And so I could make that 2 on the bottom. I can at this point just put it in the calculator. Because what I have is sine minus 1 of sine 82 degrees over 2, which is this because 15 goes into 32 times. But I could have left 15 and 2 there. And that is approximately, that angle gives me about 29.7. Now I could round that up to 30. Okay, I'm going to leave it 29.7 just sort of for the fun of it. Okay, 29.7. And so that one's what this one is here. This was side or angle A. So that's 29.7 degrees. 29.7 degrees. So that's 2 of the 3 things. The last one is actually now the easiest because we know that 3 triangles add up to 180 degrees. So A plus B plus C is equal to 180. Okay. And that means that's 29.7 plus, well, I don't know what B is yet, plus the C is 82 degrees, and that's on equal to 180 degrees. And if I subtract 82 and subtract 29.7 from 180, I get that B is 68.3 degrees. Now, it would have been okay if rounded. Then we would have had 30 plus B plus 82 is equal to 180. And we would have had that B is 68 degrees. And that's close enough. I'm going to stick with the 1 decimal place right now just because I want to. But the rounding it to 30 and then getting 68 would have been okay too. So let's come up here and it was 68.3 degrees. 68.3 degrees. Okay, got that right. And so those are our answers for it. Solving it means finding the 3 things that were missing. And we just did it. And we did it by using a law of cosines, and then we had enough information to use law of sines, and then, of course, the 180-degree rule for angles in a triangle. Now, this next problem shows a different type of one, actually similar in concept, except we have to use the formula a little differently. So notice here we have an A, a B, and a C, but we do not have the any of the angles. Well, when you look back at the formulas here, what we have is A, B, and C. We can put in A, B, and C and solve for angle A. Or we could put them in and solve for angle B. Or we could put them all in and solve for angle C. So in a way, we're going to go backwards here. We're solving for the angle this time. Well, that's all right. Nothing wrong with that. Let's go ahead and do that. I'm going to, and I could choose it to be a squared or b squared or c squared at the beginning. It's whichever one I want. So in other words, do I want to solve for angle A, or for angle B, or for angle C? Doesn't matter. In this case, I'm going to choose to solve for angle A. I'm going to do a squared equals b squared plus c squared minus 2bc, the cosine of A. So let's plug some things in there. That's 4 squared equals 7 squared plus 6 squared minus 2 times 7 times 6, and then cosine of A. And this is the only thing that we don't know. So now it's just a matter of doing the numbers here. 16 equals 85 minus 84 cosine of A. Be very careful about that negative 84, please, or that this looks like it would be a 1, but it's not because of the multiplying that's here between 84 and cosine. That takes precedence over subtracting. Okay. But what I am going to do is subtract 85 from both sides. So I get a negative 69 equals negative 84 cosine A. Divide both sides by that negative 84, and I get 69 over 84 equals cosine A. I do not need to try to reduce that fraction, even if it could be, it might be. I'm thinking a 3 can go into both, but you don't need to. Instead, use the calculator. Cosine minus 1 of 69 over, make that a good 9, over 84 is going to give me what the angle is. So when I put that into the calculator, with the cosine minus 1, I get that alpha is approximately 34.8 degrees. So I now know, if I'm going to solve it, okay, I now know that angle A is approximately 34.8 degrees. So that's one of my answers here. Now I have to find the other angles. Well, at this point, now that I have that, I can actually use the law of cosine, because, let's make an arrow here, I now know angle A to go with this. That angle A is 34.8 degrees. So I can put these two in law of sines, and neither one of the other ones. It doesn't matter which one. So I'm going to do B. So actually, let's think of this as my first thing was here, first step. And then now my second one is here. So I'm going to use the sine of alpha over A, or sine of A over A is equal to the sine of B over B, because I know that A is 34.8 degrees. And I'm going to divide that by the amount of A, which is 4. And the sine of B, I don't know. But I do know that the amount of B is 7. So if we multiply both sides by 7, so multiply by 7 on both sides, and I now get 7 times the sine of 34.8 over 4. And I put that in the calculator, and actually all of that, I do sine minus 1 of that whole thing, 7 sine 34.8 over 4, and that gives me approximately 87.1 degrees. Okay, so I can leave it 87.1, or I can make it 87. Since I made that one a decimal point, I should probably keep this one that way as well. Okay, so I'm going to yellow in those first. And now that I do that, 87, so angle B is approximately 87.1 degrees. So now we need to know what C is. In fact, I should get with these. So our next step, angle C is approximately what? Well, now that becomes an easy thing. Okay, so for angle C, Well, angle C plus angle B plus angle A is equal to 180 degrees. If I have two of the angles, I would know what the other one, or I would then use it with the other one. So B is an 87.1, and A was 34.8 equals 180. Oops, no, plus. So add these together, subtract them from the 180, and angle C is approximately 58.1 degrees. That's right, that one. Neatly. 58.1 degrees. And let's put it back up here, 58.1 degrees. Yeah, so now we have our answers. We've solved it because the three things we didn't have were all angles. We had the three sides, but we didn't have the angles. Now let's take a look at something called Heron's formula, which is simply a method of finding the area of a triangle, but you can use, okay, that's what I wanted. Area of a triangle. So what we use is this S a bunch of times minus ABC. So S is half of the perimeter. So what we need is to find the perimeter. A, B, C are the side lengths. So we're given these side lengths for this problem, A, B, and C. I want to know what S is, so what I need is the perimeter. So I do 7 plus 10 plus 15, okay, and that equals to 32, but the S is equal to 1/2 of the perimeter. Perimeter. All right. So that means S is equal to 1/2 of 32, which is equal to 16 units. So S is 16. So the formula is that the area of the triangle, we're going to use this one here, it's the square root of, well, 16, following this thing. We'll do 16, then 16 minus A, and so on. 16 minus 7. And if I'm right, it's just simply each one of them in order, okay? 16 minus 10, and 16 minus 15. So this was A and B and C. And then after that, it's just a matter of calculating it out. So that's equal to 16 times 9 times 6 times 1, right, which is a pretty good size number, but still 864. Okay, so area of the triangle. And the square root of 864 is approximately 29.4 units. But remember that this is an area, so it's square. Right, so because you multiply two things that included the actual units being squared. So we're looking at 29.4 units squared. And that's how it's done, is you add up to get the perimeter, take half of the perimeter, 16, and then in this case you use that 16 a bunch of times, with the parentheses, each one of them, and you get numbers to multiply and take the square root. So that's the area of that formula for you to draw it out, but we didn't need to here in this case. So the last page here is sort of a summary of when to use them. Now, for the law of sines, one of the things, this is when you have two angles and any side. So, and the reason you can do it with two angles, well, is because you can get the third side easily by doing A plus B plus C is equal to 180. So you can then match a side and its angle, meaning the one that's across from it. Okay. So sort of as an example would be, if I knew this was 30 degrees and this was 20 degrees, I would then do 180 minus 50, so I get 130 degrees for the other one. And if I knew this amount is, say, 15, and the other ones, it doesn't matter. Let's say this amount is 10. So I would then know 130 here, and I could do sine of, we'll call that A, sine of A over A is equal to any one of the others. Let's take sine of B. And so that means now we know A, and we know B, which means now we only have one thing to solve for. If you calculate that out correctly, you would get B. And you can do that because with two sides, or with two angles, I should say, with two angles, you can get the third side easily. Now, then another one for the law of sines, right? This is when you have any an angle and its opposite side and one other thing. Either angle and one other, and that other thing can be, we'll get the word thing in there again, and that thing could be one of the angles or one of the sides. It doesn't matter which one it is. So what you need is an angle and its opposite side length. So it would be as if this was, well, 130 and 15. And then if this amount was 10, we would then say, we'd call this one B. And so we'd say sine of 130 over 15 is equal to sine of B over 10. And because we have three things that we know and only one we don't, we could then solve for B and use the -1 key. Now, the law of cosines. Okay, so that one's used when you have two sides and their included angle. Two sides and the included angle. So that means like having C and then having A and B. This is exactly what we had in the first problem in this section. And then the last one is when you have three sides. So if you have three sides, you can actually solve any of the angles. All right, so that would allow us, so now you can solve for any of the angles. So that would be as if we had A and B and C, or whichever combination. So we had it the other way. B and C, doesn't matter. And we could then get the angle for any one of them. Okay. So for law of sines, two angles in any side. Law of cosines, two sides and the included angle. An angle and its opposites for doctor and three sides. And that allows you to solve any of the angles. So what we've looked at here was using the law of cosines if it fit where we had an angle and the sides that were not with the angle or opposite of it. And then we would solve triangles. Let's see, that was the first one. We had the angle and the sides and the lengths of both sides. Here we have just the lengths to work with. that if you have just the lengths to work with, then you can get any one of the angles you want to, which we then found out over here. And we used Heron's formula to get the area of a triangle. And here we had reminders about when to use the law of sines or the law of cosines. Well, I hope this helped to understand using the law of cosines for this, and thank you for watching and listening.